Bismillah ar-Rahman ar-Rahim. In this video, I will talk about the first lecture of Math 111. المقرر هذا يدرسونه طالبات وطلاب السنه التحضيريه بجامعه الامام عبدالرحمن الفيصل. So the first chapter is about basic algebra. هذه المواضيع اللي راح تدرس في first chapters. Okay. So أول topic we will talk about is sets اللي هي المجموعات. راح نتناول أول شيء تعريف المجموعات definition of set. Okay. So what does it mean set? A set is a collection of objects. We can think of set as a box containing some objects which are called its element or members. So just imagine the set is a box, and inside the box there is an object. Each object of those box is elements or members. An example of sets, a set of letters in the alphabet. So A, B, C, and so on. Also a set of people in this classroom. Let's say we have 24 students in the classroom. Each student in the classroom is a member of the set. Also we have a set of everything in the classroom. If we can think of the classroom, for example, the AC is a member of this set, the table, the desk, the board, the students in the classroom. So everything in the classroom is a member of the classroom, of the set. Last example is a set of even numbers, 2, 4, 6, 8, and so on. So this is an example also of a set, and each number is a member or an element of our set. Okay, now sometimes a set's elements are highly specific, so we use definitions or different ways or notations to describe our sets. Okay, so let's see, the first way to describe the set is the roster notation. Okay, so this is the first way to describe a set. The roster notation is described by listing all its elements. فقط نضع كل العناصر, and in between braces and separated by commas. Okay, so in between each element we put the comma. Most of the time we use capital letters to name a set. Okay, as you can see here we have example of sets. We use capital letter to name the set. If a set has too many elements, okay, to list, we list some elements, then we use the ellipses, as you see here, because we can't just keep going and write the even numbers to the infinity. So we use these 3 dots to specify that this is going for to the infinity. Also here, because we don't want to list all the alphabetic letters. So as you can see here, we use these braces in between the elements. Okay, and also we use the comma. We use the comma in between the elements. Okay. طيب. Sets notation. We have an example here. Write each of the following sets in a roster notation, the sets of digits. Okay, before we start to write the set, let's think of what does it mean by digit. Okay, digits is the numbers that contain only all the numbers or the single numbers. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is all the single numbers or the ones, let's see. Okay, so this is the meaning of digits. Also, what does it mean by whole numbers? And we need to know also what does it mean by natural numbers. The whole numbers are the numbers from 0 to infinity. So 0, 1, 2, 3, and so on. And the natural numbers are the numbers that start from 1, then 2, 3, 4, and so on. Okay. Now we can start to write the sets. So the sets of whole digits, we don't forget the braces and the comma in between the elements of the sets. Also the sets of whole numbers, we write the braces, then we start writing 3 or 4 members of the sets, then we put the ellipses. For C, the questions ask us to write the sets of whole numbers greater than 5. So we have here condition, okay? So since the question says greater than 5, يعني أكبر من الخمسة, so we have to start from 6. So 6, then 7, then 8, and so on. Okay? The sets of natural numbers less than or equal to 5. So we gotta start from 5 because it says less than or equal. So we start from 5, then less than, so we write the numbers that less than 5, which is 4, 3, 2, and 1. Of course, we don't forget the braces and the commas in between the elements. Okay, now the other way to write a set is by using the set builder notation. In a set builder notation, the elements of the set are described by listing their properties, but in a more symbolic way. Okay, let's see now what's that mean. For example, we have x, then such that x is a whole number and x more than 5. So I'm going to write this set in the roster method. So 6, 7, 8, and so on. So if I want to write this one in the set builder notation, I will start with a known value, which is x, then this simple, which means such that, then I will describe my x. So my x here is a whole number, okay, and x more than 5. Okay, now let's see some examples about this this way. Example 2. A whole number n is a perfect square if n equal k square. So what this is, just tell us what does it mean by perfect square. Any number I can say that this number is a perfect square if I can write it as k square. For example, 5 is not perfect square because I don't have number, I raise it to power 2 to give me 5. There is no number here. Okay, so this is not a perfect square. But 4 is a perfect square because 4 is 2 to the power 2. Also, 16 is a perfect square because 16 is 4 to the power 2. 25 is a perfect square because 25 is 5 to the power 2. Okay, so now since we know what does it mean by perfect square, let's see the question. Write where k here is a whole number. Let S be the sets of all perfect squares. If S is a set of all perfect square, write the sets in the roster notation. So how can we write S in the roster notation? So of course we will name the sets as as the question tell us. Then equal, then the braces. Okay, then we will start to listing the elements of the sets. So the perfect square, we will start with 0. 0 square equals 0. Then 1 square equal 1. Then 2 square equal 2. 3 square equal 9. 4 square equal 16, and so on. So we will take all those numbers in our sets, as you can see. 0, 1, 4, 9. Sorry, this one is 4. 2 square is 4. Okay, 9 and 16 and so on. Okay. Okay, how can I write this in a set builder notation? Okay, so we will start with the braces, then with the n-known value n, such that n equal k square, n equal k square for some whole numbers k. So we have to identify what is k. K is a whole number. I'm gonna try and check a whole number n is even if n equal to k. So this is the definition of the even numbers. We can say that n is even number if n equal to k, where k is a whole number. Okay, let T be the set of all even whole numbers. Now, write the set T in a roster notation. So, in order to write a set in roster notation, we write T, then equal, then the braces. And now we set all the elements in that set. So first, where k is a whole number, so the whole numbers is 0, 1, 2, 3, and so on. Now, our n that is in our set is 2k. So 2 times 0, then 2 times 1, then 2 times 2, then 2 times 3, and so on. So the first element will be 2 times 0, which is 0. The second element is 2 times 1, which is 1. The third element is 2 times 2, which is 4. And then 2 times 3, which is 6, and so on. How can we write this in a set builder notation? So same things, we will write T, then braces, then we will write n, such that n, now we will define our n, since in the question they already define it, so n equal to k because n is an even number. Okay, so we'll write n equal to k, then comma, we can write k is a whole number, or for some whole number k, for some whole number k. Okay. A membership of an element, the simple, those two simples. What are those two simples that we use with the sets? If an object A is an element of a set, if an object A is an element of a set S, then we write A belongs to S. How can we write that? We can say A belongs to S, or A is an element of S. And if A is not an element of S, then we write A does not belong to S. So A does not belong to S, or A is not element of S. For example, we have here 1. So 1 is belong to, 1 belongs to this set because it is one of its members. And 8 here is none of those elements. Since none of those elements is 8, so it does not belong to this set. The first type of set is the equal sets. If we have two sets S and T, we can say that they are equal if they have the same elements. So exactly all the elements in S are also elements in T, and all elements in T are also elements in S. Okay, so we read that as S is equal to T or S equals T. Okay, so as we said, this means if S and T are not equal, that means S does not equal T. Now let's see some examples. We have this set 1, 2, 3 equals 2, 2, 3, and 1 equal 3, 2, and 1. We can see that they have the same elements, but the order of the elements is different, and this is doesn't matter in the sets. Okay, يعني الترتيب العناصر لا يعني أي شيء. Okay, في المجموعات. So that's why we can say here that this set equal this set equal this set. But this set does not equal this set, since here we have 3 elements and here we have only two elements. And 1 here does not belong to this element, to this set. Okay. The other types of elements is the singleton set. A singleton set is a set that contains only one element. For example, this set, it has only one element, which is A. So we call this as a singleton set. Also, we have the empty set, which we represent the empty set with this symbol. We call this phi. And the empty sets means we have no element inside the set. And we can write that as this. Okay, so as you can see, there is nothing inside the braces. Okay, also we have the subset of a set. The subset of a set, if we have S set and it is a subset of another set which is T, we can write that as S is a subset of T. Okay, as you can see, we can see that S is completely inside the set T. So all the elements of S are also elements of C. But in this case, we can see that there is some elements over here, okay, are not elements of T. So S is not a subset of T. Okay, we call this a Venn diagram. Let's see also here, list all subsets of a set 1, 2, 3. So first of all, we will set the subset that contain no element, which is phi. Then we will set the subset that contain one element, which is 1, then 2, then 3. Then we will set the subset that contain 2 elements. So we will take 1 with 2, then 1 with 3, then 2 with 3. And last, we will list the subset that contain 3 elements, which is 1, 2, 3, and that's it. Now let's say we have this question. List all the subset of A, B, C, D containing A. So here we have one condition containing A. Okay, so if you want to set all the subset, we will have 16 subset, because we have this rule to know how many subset do we have. 2 to the power 4, which equals 16. Here we have 8 because 2 to the power 3 equal 8. Anyway, we don't have to memorize this one, but I just wanted to tell you how many subsets do we have in all. But since here we have this condition containing A, so we will just include the subset that has the A element. So I'm not gonna write phi this time because it does not contain A. So I'll start with subset A. Then I will write the subset that has two elements, AB and AC and AD. Then I will write the subset that has three elements, including A. So A, B, C, and A, B, D, and A, C, D. Then the subset that has all elements, which is A, B, C, and D. So those are the subset that contain A. Okay, now we have the set operation. We have two operations we'll talk about so far. So the first one is the intersection of sets. And the intersection of two sets, S and T, is the set S intersect T. Okay, and this means it's X such that X is in S and at the same time X in T. So we are talking here about all elements that are in the first set and in the second set at the same time, which means here. So let's see, we have this set 1, 2, 3, 4, 5, and the other set is 0, 2, 4. So the elements that are in both sets, 2 and also 4, they are in the same in the both sets. So that's why this set is S intersect T, if this is set S and this is set T. Okay. What about the disjoint set? We can say that S and T are disjoint sets if the intersection equal phi, which means they are separated. There are no elements in common. Okay, so all the elements in S are totally different than the elements in T. That's why the intersection equal phi. Okay, for example, we have the even whole numbers and the odd whole numbers. Okay, those two sets are disjoint. Why? Because they are completely different. يعني ما في عنصر يكون زوجي وفردي في نفس الوقت. So that's why مجموعة العناصر الزوجية الإيفن ومجموعة العناصر الفردية الأود are disjoint. ما في بينهم عناصر مشتركة. The second operation is the union of sets. The union of two sets, S and T, is S union T. We can write it as this, and it means X such that X in S or X in T. Okay, so it's enough for the element to be in one of the sets, to be in the sets of union. Okay, let's see, for example, we have this set 0, 1, 2, 4 and the set 1 and 3. So the union, we will put all the elements, but we will not repeat any element two times. For example, here we have 1 and here we have 1, so we will write 1 only one time. Also, we will put the other elements so far. So here we have 0, 2, 3, and 4. So basically, you have to write everything, but without repeating any elements. Okay, any element. Let's see this example. We have set A and set B, and we are asked to find out the intersection and the union, and and they ask here, is A a subset of B or B a subset of A? So let's see part A. The intersection, since in the intersection we are looking for the element that in the same, in the both sets. So we can see here 4 and 4 in both sets. So the intersection is 4. But in union, we are looking for all elements. So we will set the elements of set A, then we will add the elements of set B. Of course, here you can see that A is not a subset of B. Why? Because 1 is in A but not in B. And also 5 is in B and not in A. That's why B is not a subset of A. Okay, so none of them is subset of the other. Let's see this exercise. Consider the two sets A and B. Find the intersection and the union. So as you can see, here we have 1, 3, 5, 7, and here 2, 4, 6, and 8. We can see that there is no element in common. Okay, that's why the A intersect B equal nothing. Or we can write phi. A union B, so we will put all the elements in A, 1, 3, 5, 7. Then we will put the elements in B, which is 2, 4, 6, 8. If you like, you can put those numbers in order. For example, you can write 1, 2, 3, 4, 5, 6, 7, and 8. Okay, here just a review of the notations, the empty sets, okay, and the natural numbers, the whole numbers, and equal and does not equal. Here's the symbols of more than or greater than, less than, greater than or less than or equal, more than or equal. Here is belongs to and does not belongs to. This is the intersection and this is the union. This is the subset. And we call this also the Venn diagram. Okay, we have some problems over here. We can solve them together also. So here we have let A be the set that contain X, where X is a whole numbers and the square is equal to itself. So it says that determine whether one belongs to A. Let's see first what is the set A. Let's write the elements of set A. So whole numbers, and we said that the whole numbers is 0, 1, 2, 3, and so on. Okay, but there is condition here. Square, whose square is equal to itself. So let's write this. Whose square, so it means if this has X, that means X square is equal, so equal itself, which is X. So what's the number? You ask yourself, what is the number that if we square it, you give us the same number? You can see that 1 square equal 1, and also 0 square equals 0. So 2 square does not equal 2. So only those two numbers are in the set of A. So we have 0 and 1. Now let's answer the question. Does 1 belong to A? So yes. Okay. Now let's see. Now, as you can see, this is 1. Now let's see number 2. if A equal 1, 2, 3, 4, 5, and B is X, where X is a whole number, and 2X belongs to A. So as we said before, we have to write B, set B, to list its element. Okay, so let's see. It says that A is a whole number, so it could be 0, 1, 2, 3. Now let's see the condition. 2X belongs to A. So if we multiply 0 with 2, we will have 0. Does 0 belongs to A? No. So we will not take 0. Now let's multiply 1 with 2. 2 times 1 equal 2. Does 2 belongs to A? Yes. So we will take 1. Now let's try 2. 2 times 2 equal 4. Does 4 belongs? Yes. So we will take 2. Now let's try 3. 2 times 3 equal 6. Does 6 belongs here? No. So we will not take 6. So we're gonna stop in this in those two values, because even if we try 4, it will not belongs to A. Okay, so the set B will be equal, containing only two values or two elements, which is 1 and 2. And now let's find A intersect B. So A intersect B, we were looking here for the values that has the values that are in both sets. So 1 is here, and also 2 is here and here also. So 1 and 2. Now let's see number 3. If C equal 3, 4, 5, 6, and D equal X is a whole number and X more than 1. So first we will write our set D. Whole number, the whole number, as we said before, it is 0, 1, 2, 3, and so on. But there is condition here that X more than 1. So we will start after 1. So we'll start from here. So it would be 2, 3, 4, and so on. Okay. Now the question is C subset of D is C subset of D. In other words, does all the element in C as elements in D? So 3 in C and also in D, 4 in C and also in D, 5 also would be here, and 6 also. So yes, C is a subset of D. Okay. That's all for the first lecture. Thank you for watching.